Let's show Leetcode 1679 max number of k-sum pairs. This problem is also part of the 4th May 2022 Leetcode challenge. In this problem, we are given an array nums and an integer k, and we need to find out the number of pairs which sum to k. For example, in the given example, that is example 1 on Leetcode, consider the array 1, 2, 3 and 4 and k is 5. There's only one pair, that is 1 and 4, which sum to 5. So first of all, what we can do is, we know that for any integer a, there will exist a unique integer b, right? Such that a plus b is equal to k. So if we know the count of a, let's call it na, and we know the count of b, let's call it nb, the number of pairs which a and b can form is minimum of na comma nb. So let's keep a map which stores the count of a and b. So we'll keep a map. Now there are two types of map. There's an unordered map and there's a normal map. So unordered maps gives us a time complexity of order of 1 in the average case, and in the worst case it will give an order complexity of order of n in the worst case. So what we can do is we can store the count of every element, and then when we can traverse the map, and then we can find out the number of pairs for each element and store it in the answer. Now this answer will contain answer for both pairs like a and b and b and a, but since both a and b and b and a are same, we'll have to do, finally when we print the answer, we'll have to do a answer by 2 because a and b and b and a are the same. So let's understand this better by the code. So first of all, declare an unordered map of integer and integer, and let me call it counter. In this counter, I'll store all the count of the elements present in the array nums. So for all the elements in nums, I'll store their count. Now when I traverse over this counter, x dot first in C++ gives us the actual element, and x dot second gives the count. So for a particular element x dot first, if counter also contains k minus x dot first, then we can say that we can update the answer as minimum of x dot second, that is the count of x dot first, and the count of k minus x dot first. So let me quickly declare the answer variable as well. Now we'll return answer by 2 because we have counted both pairs a comma b and b comma a, but in reality they should be the same, that is a comma b is the same as b comma a. So we'll be returning answer by 2 as a comma b and b comma a type of pairs are the same. So let us quickly look at the time complexity. So we are traversing the all the elements once using this counter. So, and this counter dot find operation is an order of 1 operation in average case, and the counter element plus plus is also an order of 1 operation in the average case. So finally it turns out to be order of n in the average case, and order of n square in the worst case. So we'll comment this as the time complexity with unordered map. And now instead of unordered map, if we would have taken only a map, then the time complexity would have been the same in all the cases. So it would have been order of n log n, because all the operations with a map are login. So this would have been a login operation, and this would also have been a login operation. So we're traversing n times and we're doing a login operation. So n login, and this would have also been, we'll be traversing n times and doing a login operation. So n login plus n login, that gives us a 2n login, which is same as n login. So order of n login with a map. And regarding space complexity, so space complexity, we're using a counter, and it will store the distinct number of elements and their count. So it will also be an order of n. Now let's run the code. Okay, we are getting a compile error. Okay, I deleted a parenthesis from here. Let's run it again. Okay, the first case is passing. Let's run all the sample test cases. Okay, they're all passing. Let's submit it. Yeah, so it is working perfectly fine. If you like this video and you found this helpful, please consider giving a subscribe to this channel and giving a like to this video. Thank you so much for watching.